Hello everyone, welcome to Coders Camp, and today we are going to start a series of videos that solves medium to hard problems from LeetCode using binary search. And we have came across a lot of problems that deals with binary search solutions, but at first go we cannot figure out it is using binary search. So I'm going to discuss those kind of problems here in this video series to help us understand how we can approach a problem using binary search logic. So let's first start with this problem, capacity to ship packages within D days. The problem statement says a conveyor belt has packages that must be shipped from one port to another within D days. And we have to return the least weight capacity of the ship that will result in all the packages on the conveyor belt being shipped within D days. Let's understand this problem with an example. The input given here is the weight of items in the conveyor belt. That is, the problem statement says there is a conveyor belt and has n number of objects, and each of them having corresponding weight, say weight 1, weight 2 to weight n, and that is the input given here for us, and they have specified number of days we need to take to ship all these items to another place. So here in this problem we have 5 days to ship all the items to the port or from this place to another place. In this case we can upload or we can send the set of packages from this conveyor belt in order only. From starting from 1st to 5th or 6th you can send us one package, and then the rest of the packages we need to send. For example, if the port is taking in a container first day the weights 1 and 2, it goes and drops the items there and come back with an empty container, and again the rest of the weights will be filled and then shipped. Here the condition given is we cannot load ships more than its capacity, and we have to return the minimum weight needed so that we can send all these containers in this number of days to the other place. So how are we going to approach this problem? Consider we are sending or loading the ship with each item per day. In that case, the overall minimum weight the ship can hold is the heaviest weight in the given input. That is, we cannot divide this item into 2 or 3 halves and send it to a ship. We can completely put this item in the ship. In that case, if we are putting one single item itself, then in that case the minimum weight that ship can carry would be the maximum weight given here in the conveyor belt. So the weight can be start from 10, that is the maximum weight out of all the weights given, and if we are shipping all the items in one go, then the total sum of the given all weights is going to be the minimum sum we can send into the ship. So 55 is the sum of all given weights. So the actual minimum weight we needed is residing between 10 and 55. That is the heaviest weight in the conveyor belt to all the weights given in the conveyor belt. So we clearly know there are limits. That is the weight resides between some 10 and 55. That is from left to right limits given. So in this case you can clearly figure out it is a binary search problem. That is, our answer resides somewhere between the sorted numbers 10 and 55. So as per the binary search logic, we are going to consider our lower limit as 10 and higher limit as 55, and gonna find some mid-weight and check whether if we can load the ship with that mid-weight and export all the items within 5 days or given D days. If that is true, we are going to return the mid value as the weight or as the minimum weight we need to load the ships. If not, if we cannot load the weight within the mid values, then we are going to set our pointer left to after mid and check the range after mid to the highest value. If not, we can send all the packages within less than D days using this weight, which means this weight is more, So in this case, we have to set our right pointer this side and check the possible weights between the lowest weight and the mid and return the value. So by using this logic, we are going to code and get a result. So let's go for a dry run and then get into our code. So the minimum weight or the lower limit is going to be 10 and the upper limit is going to be 55. First we are going to check the mid value, that is 32, and whether we can, using 32, we can ship all the items within 5 days. So in our day 1 we can ship items 1 to 7, which sums up to 28. If you add 8 to that, it will become more than 32. So we are sticking to 1 to 7 and shift the rest of the things on day 2. On day 2 we can send 8, 9 and 10 all together as single package. So instead of 5 days, within 2 days, if we use or if we send maximum weight of 32, we can ship all the items, which is actually very less. So we can have rest of the 3 days to ship items with lesser weight. So we are shifting our upper limit to 32 and the weight somewhere reside between 10 and 32. So now the mid is going to be 21. So we are going to check by using 21 whether we can ship all the items within day 5. So considering on day 1 we can ship up to 6 weights, that sums up to 21, and then on day 2 we can ship up to 7 and 8. On day 3 we can ship 9 and 10. So here we have finished within 3 days, but we have still 2 more days left. In this case, this is also extra weight. So the limit again exit between 10 to 21. In this case, we are again going to determine our mid value. Our mid value is going to be 15. So we are going to check on day 1, we can send 1 to 5. On day 2, we can send 7 and 6, because if you add 8, it will exceed 15. So on day 3, you can send only 8, because if you add 9, it will exceed 15. On day 4, you can send 9. On day 5, you can send 10. So by using 15 as the weight, you can send all the packages in 5 days. So 15 is going to be the minimum weight we need every day to ship the packages. So this is going to be our output. Let's see how we're going to code it. So as I said, I'm going to have my left and right pointers. And I'm going to calculate the maximum value in the given weights and the sum of given weights. So once we calculated the limits of left and right, I'm going to loop in and calculate my mid. So I'm going to have a variable days to calculate the number of days we are sending the packages. I'm initializing that to 1, and a variable current, which is going to hold the current weight we are sending. So I'm going to iterate through my weights array and add my current value, that is if my current weight plus one more weight is greater than mid, then that is the case, we are done for that day and we are shifting the rest of the packages to the next day. So we are going to increment the days to one more day and then set our current container's weight is equal to 0, because once we shift the weight, we are getting our empty container to fill in the rest of the items. So we are going to add current weight every time we iterate. So once we iterate every time the current weight, and if it goes greater than the mid value or the weight we estimate, we are going to add days and ship the items. Once all items are shipped, we are going to check if it is done within the days given or took more days than the given days. Greater than D, which means we took the lesser weight. So we have to make our lower limit more. So in this case, we shift our left pointer to mid plus 1. If not, we have done everything within the given days, then our weight was higher, so we have to reduce our right pointer to mid. So finally, once all that is done, our left will be having the exact weight which is needed to ship all our items within given days. So we are going to return our left. Let's run this. Yes, so let's submit. Yes, the solution is accepted. And for more binary search videos, check the link in description. So thanks for watching the video. If you like the video, hit like and subscribe. Thank you.